I'm Roberto Baldwin, and this is Tomorrow Today's Sustainable Mobility Brief. The transportation world is evolving at a rate not seen in decades. The transition from fossil fuels to sustainable energy has brought with it some truly exciting opportunities, but also some confusion. I'll sift through the noise and share quick updates on the latest news, trends, and advancements that will impact our world for years to come. This week on the Tomorrow Today Briefs podcast, we have RE Automotive CEO Daniel Burrell and VP of Engineering Pete Dow to talk about their company and commercial EVs. Thank you so much, Daniel and Peter, for joining me today. And before we start, let's tell our listeners what RE is and what currently is going on with the company.
Thanks for having us. RE is a tech company that designs and builds very advanced vehicles. Those vehicles are basically software-defined vehicles, which means software-defined vehicle means that it's a vehicle that manages its operations and features through software, and that driving higher efficiency, better comfort, and improved performance. SDVs, for short, software-defined vehicles, allow for advanced driver assistance systems and enhance, autonomous driving capabilities, which everybody's talking about today. And in addition to that, because it's software-based, the ability to introduce new features and improvement via over-the-air updates throughout the lifespan of the vehicle, making SDVs highly adaptable and basically future-proof. And RE is one of the leaders in the industry today on SDVs. We are publicly traded on NASDAQ. We've been a public company for about 4 years. We recently just announced we kicked off the start of production of our first products to the US market, medium-duty trucks that are very naturally advanced and unbiased, but quite cool. And we're really, really excited by the growth of our reservations. It's been growing very fast. Last quarter, we reported, I think, 230% growth in reservations. We see very strong intake of our products. Customers love them. And in general, I think we're very fortunate to have, to have the right technology that basically everybody wants.
And we're talking about fleet managers. Every mile is should be making money as far as they're concerned. And so how are commercial vehicles a good candidate for electrification, whether it's fleet managers, whether it's maybe a company with maybe 2 or 3 vans, or maybe just someone with a single commercial vehicle? How is electrification helping them make money? Because at the end of the day, that's all they care about is the bottom line.
Oh, that's absolutely 100% true.
Yeah, I would say, Daniel, do you want me to? Maybe I'll comment on that, because I think, as Daniel's kind of pointed out, we've got software-defined vehicles. We've got a vehicle now that the heart of it is software. And what that allows you to do is to define a vehicle that meets the customer needs. We follow what the user needs. So how do you make money? You build and you develop a vehicle that does what you need and no more. Okay. So it may be that people we're seeing are buying trucks from a spec sheet. They'll know that they need a truck that carries a certain payload and has a certain amount of range. But if you ask a lot of people, they don't really know how much their vehicles carry or how far they need them to go. Unless you've got something like our truck, which gives you that data, we can define it for you, we can actually size it for you, and then you're only spending money on what you need to spend money on, not extra bits. So use the defined vehicles.
I think Pete is spot on that. And I'll maybe just add that in general, just having an EV not necessarily improves efficiency for fleet owners and in commercial vehicles. I mean, sometimes it's actually doing the other way around. Having the right vehicles which just happen to be an EV is really important. Why? Because if you design the right vehicle for the specific customer, and they all vary, some of them are very different from each other, right? Just as an example, I'm sure people know that or can imagine that, guys like UPS who are basically build and design the spoke and hub mechanism of ultimate, efficiency and etc. are very, very different than, I would say, Amazon in the way they operate their fleet, because Amazon prioritizes delivery times. Right, because it's a different business model. So naturally, with that major difference between them, their trucks should be different. And up until very recently, before the electrification revolution, fleets would just buy what's available on the shelf. And then it never fits anybody right. There's all compromise. And to Pete's point, with software-defined vehicles, the ability to design, tweak, and address what the exact fleet needs is critical. I'll give you just maybe you and the others a couple of examples, just to be clear. Charging a battery from 0 to 80 is more or less the same time, money, and power than 80 to 100 because of electron density, etc. Right? And where back, if you look at diesel, for example, petrol, the truck would come back at the end of the day to the depot. You top it up with some fuel and ready for the next day. But what if you don't need 100%? What if a software-driven vehicle, an SDV, REE's vehicle, can calculate very accurately with enough margins that vehicle number 54 needs only, 72% charge for tomorrow? That saves half almost of the variable cost for that fleet owner. It's massive, right? But you can't guess it. You can't say maybe, because you can't be stuck without range, right? As an example. Second example for that would be preventative maintenance. So we aggregate thousands of data stream per second from our vehicles, because they're all software driven, right? And we upload it to our cloud. And then through AI, right? AI basically, that it looks for patterns, things that you never thought of. So we run AI on it, and then suddenly patterns emerges, which you didn't think of, that maybe if A happens and B happens and sometimes C happens, D can happen, which you never thought would be linked. But suddenly that pattern appears, and you can be preventative in not getting to the failure, giving ample heads up, or fixing something on the go, or sending an over-the-air update to fix it, and so on and so forth. That ability, to your question, is how RE, with our advanced software-defined vehicles, SDVs, actually saves money to fleet operators and in commercial vehicles.
And is the RE sort of the cloud and the software that comes with the vehicle, is it software agnostic to all the fleet software that's already out there? There's a couple of big players in the fleet software market where they're using something. They're already a company's already using something. Would they be able to plug their RE vehicles right into that and just keep going?
Well, that's a brilliant question. Our motto at RE is that we complete, we don't compete. So the absolute answer to that is yes. We collaborate. We use API handshakes, right, and protocols to allow those players that you've mentioned to, one, provide their current services, but then add on services that they've never been able to do before, and offer them to their customers to improve their efficiency, performance, capability. Absolutely.
Because to add to Daniel's point, the data we've got available is significantly larger than you'd normally get in a conventional vehicle, because we own the software and because we've developed the software ourselves. Things like an ABS system, you'd be going to a supplier and they would only give you 1% of the data from their system, whereas we've got all of that data available because it's ours. So you can use the data, and we can help to guide the fleets, the users, etc., with that data. So it's useful, because data is not of any use to people if they don't know what to do with it, and we can help with that as well. But you've got access to much more about the vehicle than you would conventionally have.
Like electric vehicles don't have like oil changes, etc., but brakes, because you have this data, because you have regenerative braking, could you potentially say, okay, the brakes on truck number 12 will likely need to, the brake pads will likely need to be changed in 18 months versus just sort of waiting until you hear the squeal.
Oh, even further than that, you would know the brakes on the front left of truck number 12 you've been kind of worn to a state where you should be looking to kind of replace them at a certain time. We understand the pressures that are happening inside the cylinders, inside the caliper. We know all of that data, not just for a vehicle, but per corner. Let's go back to the RE corner concept. We've got it per corner.
It's really important when you talk about braking. For example, we actively monitor the payload. Not only the payload, but where is it distributed in the vehicle? And we apply braking accordingly. So imagine a scenario, which is not a good scenario, where somebody, loaded the vehicle where everything is on the left side, right? We would be able to tell you about that. Not only that, let's say you now have to have an emergency braking while turning left. There is a high chance that if you do it without knowing, you can flip over. But we can monitor that, and to this point, we can moderate how we use braking in each of the corners of the vehicle. Maybe putting more brakes in a certain point, less brakes in another point, using our motors to generate more braking power, and so on and so forth, giving you a shorter braking distance and much safer braking. And that's not derived just because we're developing and building EVs. It's because of the software behind it. It's the software and the SOC, the system on chip, the hardware bit of it that makes it all run.
Because you wouldn't want to turn left, you wouldn't, everything's on the left, you would want to drag that rear right brake. That I would assume. That's it.
Well, but let's just think about this. We've got four corners on a vehicle, and to actually turn a vehicle, you can use the steering system. So we've got 4-wheel steer on our vehicles, so we can use both front and rear steering. We can use traction, and we can actually use brakes. So we've got all of these different means of actually creating a yaw on our vehicle. And we do extensive testing. I'm based in the UK here. We've got a lot of the test team here in the UK. And we look at optimizing our own system in terms of active yaw, ABS systems, traction control systems, to give you not just a safe operating vehicle, but one that actually means you feel very assured driving it. The feedback we've had from people driving our trucks is, this is like driving an SUV. This isn't a class 5 truck. This is like getting in your car and driving it. I feel safe, I feel stable, and I feel like I can manage this truck really easily. And that's from the software's ability to control all the 4 corners independently within our algorithms to the optimum for that vehicle.
So when you show customers, potential customers, that all-wheel steering, what is their reaction? Because I know my reaction just in large vehicles, whenever I have all-wheel steering, I'm like, why isn't this on every large, just passenger EV? And I drove one of your prototypes a few weeks ago, and it was the turning radius was very, very small compared to what I anticipated. What are you getting? What are you hearing from your customers, potential customers?
Usually it starts with wow. No, honestly, I mean. It's very different, right? Because on one hand, it's very complicated to actually exercise, to materialize, because you don't want to create motion sickness in one hand, that you drag the rear and it feels different. You want to make sure that, like we said before, that you drive the vehicle, you feel very safe. It feels that the vehicle is doing what it needs to do without you knowing if you're using all-wheel steer, front-wheel steer, rear-wheel steer, torque vectoring, and so on and so forth. You shouldn't care. Just want to turn, right? So it needs to feel natural. And the ability to make it feel natural, as easy it might sound, is actually quite complicated. The actuation itself, making the wheels turn, is not that complicated. But putting inside of a system that will feel right is different. Vehicle dynamics is one of the really fine arts in automotive, right? And not only in trucks, in passenger vehicles as well. Our technology is applicable for passenger vehicles as well. And right, a lot of people think about passenger cars, right? Most OEMs have different, I would say, DNA in how they like their vehicle dynamics to be. And sometimes it's very difficult to come to that specific one. It takes a lot of engineering, but software-wise, you can literally tune it. And now going back to commercial vehicles, for example, let's say you have 2 drivers on the same fleet, and they drive very differently. One is, I would say, have a heavier foot than the other, right? But you want to make sure that the wear and tear on the vehicle remains the same. So the software can actually, the SDV can learn from the driver behavior and then tune the vehicle in a way that it will yield the same performance, although driven differently.
So different profiles will still, you have different driver profiles, and even if you have different drivers, you'll still retain the same performance. Which for that person who's running that fleet, who's looking at those numbers, you don't want Mr. Leadfoot or Mrs. Leadfoot like destroying your profit margins.
And it happens. It happens actually quite a lot. It happens quite a lot.
Yeah. So maybe just maybe also pick up on your rear steer point. The really visible bit is the turning circle. As you said, you get into it and you kind of you've got an incredible turning circle. But the unseen bit is what we can do in terms of the safety and stability, the vehicle dynamics that Daniel was talking about. We use our rear steer, for example, at high speeds during a lane change. So if you think you're doing a high speed lane change, you're throwing the kind of momentum of the vehicle one way and then back into the lane again. By using the rear steer, you can actually do parallel steer to bring you into the lane, bring you back again. Very similar to what a lot of the high performance vehicles like Ferrari, etc., are doing with kind of small bit steer. And actually, that's not noticeable to the driver. We don't want it to be noticeable to the driver, but it's stable, it's safe, and it means as I said earlier, you're assured in driving it.
Because it increases stability, because if the front tires are turning and the rears aren't, that means you're sort of you're sort of fighting the rear tires, which have a forward motion, which means because you have a vehicle full of cargo, which is heavy, you're sort of pushing that especially the rear outward. But if everything's turning in parallel, it's you don't have that forward motion for everything, because everything's sort of sliding to the left.
Yeah, exactly. And also maybe going back to Daniel's point about being able to take the driver profile, if you like, and adapt the vehicle to it. My background is I'm 30 years in automotive, and in every car company you have somebody who is considered to be what we used to call the golden backside. They're the ones that know what the vehicle is going to be like. Well, everybody can be one of those now. You don't have to have the one special high performance driver that's going to tell you how your vehicle's going to be. Every person that drives our truck is the special one. That's what it will be adapted to.
Let's talk a little bit about how the cabin area is different from, say, a regular, passenger vehicle. I don't think a lot of people realize, they don't realize when their delivery driver or someone shows up that the cabin of those vehicles are vastly different. Let's talk about the cabin for the RE vehicles.
Well, I think to start with, because we have our corner technology, you can actually put the corners where you like. We've got a platform. But it means that we have our P7C one. We've actually got the driver in front of the front axle. There is no axle because we're corners, but it's located where it would be. And that means he's got a very low step-in height to get into the cab. Your 2 steps to get into the cab, which from a delivery driver's point of view is brilliant. He's not kind of hurting his knees every time he gets in and out of it. And then once he's in there, you've got a very spacious and very open cab, because we've got the ability to put the steering wheel wherever we like again, because we're not hard fixed with any steering racks or mechanical linkage to the wheels. So we can give a cabin space that is, first of all, much more spacious. You're not cramped. You're not kind of sat on top of an engine or kind of high up. And then visibility wise, I mean, Roberto, you've driven the truck. You can see everything. You can see almost in front of you, which from a safety point of view, pedestrian point of view, is incredibly good as the driver. So you've got visibility, you've got the ergonomics of getting in and out really easily, and then you've got a good space to do a lot of things with it in terms of storage, etc.
And maybe I'll add to that our cabin, as spacious and driver centric as it is, also have direct effect on reducing the bottom line for the fleet. And you go like, okay, but how does it link? So very easily, actually, one, driver fatigue, injury, etc., with lower stepping height, more space, better sitting positions, better maneuverability, done. But also driver retentions. It's there's a global lack of drivers, right? And certain delivery companies have more or less doubled their driver salaries in order to retain drivers. Right? And now what we've seen, one of the feedbacks we're getting from our customers is this: the RE truck is a truck that drivers would like to drive. They would be willing to stay and actually drive a RE vehicle, which, if we're honest, it's understandable. We all want to ride something that is more comfortable, more spacious. I mean, why wouldn't we? And it affects the fleet's ability to operate, retain their drivers, deliver more, or
It's very interesting the cognitive stress that you get from having something that's making noise all day. You're sitting in a loud, this hum of a vehicle of a gas motor, and the vibration like that. I don't think people realize that when these drivers are all day, it's just boo, 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 and vibrating. Whereas in the EVs, it feels almost night and day when you're driving them.
Not only that, I remember the day that Peter and the team came to me and said, you have to choose the truck's voice. And I said, sorry, what do you mean? So here is a folder with different sounds. And we now have to choose what's the sound for going in reverse, what's the sound of, ignition, regulatory wise. And at one point you go like, this is silly. And then you go like, no, actually on the contrary, it's great because you actually have direct effect on the driver and on the surrounding, and you can actually choose the right sounds for that. And it's a great opportunity to experience the vehicle and ease the driver's, time in the vehicle. And we took it very, very, very seriously, right?
Whenever I talk about EVs, people want to talk about the grid. There's always the concern that every EV is going to plug in at the exact same time and pull, 350 kilowatts of power and destroy the grid. But can you talk a little bit about how, you talked briefly about how they're charged? Like, so what's some of the charging management that you're giving and charging information you're giving your customers?
It's a good point. And when you look at EVs, there's a lot of, I don't want to say ripple effect, but a lot of considerations to look at. Charging is one of them. For example, multi-story parking lots that have been designed to a certain weight. And suddenly every vehicle is significantly, if not double, significantly heavier, if not double in weight. Have we ever thought whether a full, parking lot full of EVs can support it? I don't know. Some could, some couldn't. There's a lot of implications. But going back to charging, I think it's more related to the use case. So, some companies would only do night charge because the vehicle goes out from the same bay every day with the same driver for the same route, coming back, for a wash, and then park for the night, being uploaded, and so on and so forth. Great, and you can do slow charge, easy. Well, there's no reason to invest in infrastructure for fast charge. Great. Some other companies would actually say, no, we actually need to do multi-route, and we need to do very fast charging as quick as we can, and off. And then what you're trying to do is you're trying to optimize not only necessarily the grid, but actually the power availability at the depot, right? Because if you've got a couple of vehicles, or if you've got a couple hundred vehicles, you understand that the implication is different. And then going back to my point earlier, do you really need to charge it all the way up? It is significant change if you can afford not to. And this is where software and then AI analyzed software is so critical.
Now, as our cities and towns, especially cities, they're filled with these commercial vehicles, and I think they're actually mostly invisible to the average person. Like, most people just don't.
It's amazing, isn't it?
Yeah, they just don't see the trucks, they don't see the vans, they don't see because they sort of blend into the background. They'll see a BMW, they'll see a Toyota, but they won't see the transit van or the e-Sprinter. It's just sort of doesn't exist for RE for a new company. Is that concerning, or is it just part of business? It's not the average person that needs to see these. It's the fleet managers. It's the people you're going out to and you're talking to.
An interesting point, because yes, there are. It is some, in a way, an invisible fleet, but it's like you never see it, and then let's say a certain day you're waiting for a FedEx delivery, suddenly every FedEx truck, you go like, I had no idea so many FedEx trucks passing by the street, I mean, it's like, suddenly.
You just keep peeking out that window. You're like, no, that's not, no, that's not mine. No, that's not mine.
Been there, done that, exactly. At the end of the day, there's a very big difference in brand awareness in commercial vehicles and passenger vehicles. Our philosophy at RE is that it's powered by RE. It's not a RE logo. Because when you see a FedEx truck or UPS truck or Amazon truck, it's a UPS truck. You don't really know who made it. And in those, for example, if you even go to, not the sprinters, but if you go to the walk-in vans, you actually don't know who built the chassis and who built the body on top of it, because there are two different manufacturers. For us, it's actually a major opportunity, because we see ourselves as a tech company. As I said, we see ourselves as I don't know, as NVIDIA for the autonomous driving or AI. You want to run AI programs, and you want to use their GPUs computing and whatever. Great. They would be happy for you to use it for everyone. Those older than our age, more or less, remember the Intel Inside slogan, right? Where it doesn't matter what you have, but it has Intel Inside. For us, that's exactly it. We don't compete. We want everybody to use our SDV technology. Passenger vehicles, commercial vehicle makers, small vehicles, large vehicles, BEV, battery, or hydrogen, because we're power agnostic. And we want everybody to use it. So the fact that commercial vehicles are more brand agnostic and they're more shadow, like you call it, shadow fleet, it's actually a major opportunity for us, if you think about it.
Yeah, I mean, if I've done my job right, then people shouldn't notice. They should be seamlessly out there. And they should say, hey, that's a cool looking truck. But other than that, it should be seamless.
Awesome. Well, thank you so much for speaking with me, Peter and Daniel. I really appreciate it.
Absolute pleasure.
Yes, thank you.
For more information about the evolution of sustainability, head on over to sustainablecareers.sae.org. There you can check out our interview with the Mercedes-Benz CEO about the automaker's upcoming software-defined vehicles. For more information about the evolution of sustainability, head on over to sustainablecareers.sae.org. There you can check out our podcast about the state of NEVI.
SAE International makes no representations as to the accuracy of the information presented in this podcast. The information and opinions are for general information only. SAE International does not endorse, approve, recommend, or certify any information, product, process, service, or organization presented or mentioned in this podcast.